Okay, now let's do an example of taking a language and attempting to construct a context-free grammar that describes that language. So here I've got a language here. It's any string of the form some number of A's, some number of B's, and some number of C's, where the total number of C's is equal to the number of A's plus the number of B's. Okay? This can be more easily decomposed if you break the C into two parts, A to the I, B to the J, C to the I, C to the J, where I and J are both greater than or equal to 0. Okay? And we would like to construct a grammar, context-free preferably, such that the language generated by the grammar is this language here. So when I try to solve these problems, I try to think working either inside out or outside in. So in this case, outside in is easier. What I want to do is I want to create a grammar that every time it puts an A on the left, it always puts a C on the right, and then you can repeat that as many times as you want. And then at some point you stop putting A's and you start putting B's, and again, every B you put on the left, you put a C on the right. It's not too hard to see that the grammar for this, so S will be a start symbol. I can put an A on the left, and if I put an A on the left, I'd better put a C on the right. And then I can repeat that over and over again. And then at some point I stop and I go to a new non-terminal symbol T. And then T will do a similar thing. It'll put B's on the left and C's on the right, putting equal numbers of both. And then at some point I can stop using the epsilon symbol. Okay? So given this language, we can construct this grammar that produces that language. So with that, let's construct a parse tree for AA, BB, CC. So I take S, I have to inject an A, so A, C, S. Have to put another A, so let's do that again, A, S, C. I'm done putting A's, now I want to put B's, so I'm going to take the T transition, S goes to T. And T can go to BTC, and once more, BTC. And then I'm done putting B's, so now I can choose an epsilon transition. What string did I generate? Reading from left to right, A, B, B, epsilon, C, 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 which is the same as this string here. Okay? In this course, we won't formally prove the equivalence of the language produced by a grammar and the description of some language. You sort of like intuitively argue why this does indeed produce this language. So it's hard enough doing proofs between DFAs and language acceptance. We're not going to bother doing proofs for grammars. You'll see that in a later course if you take theory of computation later in your degree. So not within the scope of this course. So as an exercise to you, here's another language. It's any number of A's and the same number of B's and C's, where I and N are greater than or equal to 0, or it's the same number of A's and B's and any number of C's. So I want you to write a grammar that generates this language. So it's the union of these two sets. So it's either some number of A's followed by B's followed by C's, where the number of B's and C's are the same, or same number of A's and B's followed by any number of C's. So have a go at that, and I'll do the solution in a moment.